How's it going, you guys? It's Scott with Everyday Home Repairs. Today I'm adding a circuit to this 200 amp electrical box. Specifically, I'm going to run that to an exterior outlet, and since I'm working with masonry, that'd be brick or cinder block wall, I'll be putting the box on the outside. We'll have to get through that masonry. We'll talk about how do you get the wire through that? Can you just use Romex, or do we have to run some conduit? And then we'll be using an in-use cover, which I do prefer, so we can get a water resistant seal even when we have an extension cord plugged in. Now, I have polled the audience on this topic. I've also talked to a master electrician, so I can give that knowledge to you guys and you can apply it to your DIY projects at home. But first up, I'm just gonna run some Romex from this box all the way over to that corner, which is gonna be my location, and then we'll use a hammer drill to get through that brick without doing too much damage. First up, I'm just gonna drill a 3/4 of an inch hole through this floor joist. While I'm doing that, as you'll see, the Romex is gonna run on that side, and I need to get it over one more bay to connect up with that exterior junction box. Now, unwind or uncoil that Romex before running it, and that'll just help route it later on straight. Giving plenty of slack on this end, then we'll go over to the electrical panel end. I have an existing hole that's gonna work for this 12-2 Romex that then I'll be able to pull through, getting the slack, and I do have an open electrical box here and the power is on, so you need to be careful on that wire so it's not flailing around and accidentally hit one of your bus bars. Now, once you have your slack where you want it, I'm not securing anything yet, I'm just getting enough wire in place. What I do want to do is knock out a 1/2 inch knockout on the top of that electrical box, and I'm going to install a 3/8 of an inch clamp to hold that Romex securely in place a little bit later on, but right now I just have to feed it from the top so the threads come in, and then I'll feed the lock nut from the bottom. This will take a little doing with your grounds and other wires running through. Again, taking your time. Even if you have the main disconnect off, those conductors are hot coming in, so always be careful working inside your electrical panel. Then once you have it finger tight, you can use a flat hand screwdriver and then just knock that to the final tightness, securing the clamp on the top of our box. Now, with the wire in place, and again, it's loosely in place, but we have enough slack on both ends to now go to the next step, and that is to get to the exterior here and actually mount that electrical box, and then that's going to be the determining factor. Once I have the wire I need out there, then I'll tighten everything up, we'll use some staples and get the Romex routed correctly. Now, I'm going to stay up within the cavity here of that floor joist. I'm not gonna drop my Romex down because that would actually be a little more complex where we're starting to do conduit. Here, I'm gonna keep it up in the floor joist, and then we're gonna run Romex all the way out to that electrical box. But first up, I have a rotary hammer drill and a long pilot masonry bit. So I'm gonna go outside, locate where I want that box, and I'm gonna punch through all the way to the inside, getting me my hole on my inside, and then I will size the holes correctly to get the cable clamp mounted within the brick, which needs a little bit more clearance, and also just get the hole from the inside sized correctly so we can get that Romex to the outside. Remember, when you're doing masonry, if you're going right into a larger hole saw, especially with a capable rotary hammer drill, remember, rotary hammer drills are gonna be much more capable than your hammer setting on your cordless drill. They pack a lot more punch, they pack a lot more chipping force. So if you go right into a larger hole saw and you're going from the outside in, you could have a massive blowout. Ask me how I know. Well, I've done that before and it kind of makes a little bit of a mess, and you're gonna have some patchwork or cleanup afterwards. Shooting through with a pilot drill bit is best practice, and if you guys aren't going through masonry, you just have standard stick-built framing, so you have your stud walls, you have your sheathing, some type of house wrap, and then like a vinyl siding. We'll talk about that too. This process is all gonna be the same, but obviously the masonry part's gonna be a little bit different in terms of what electrical box you're selecting. So now let's jump in. We'll start off by locating that pilot hole and drilling it all the way through. Right, so I'll use a measurement just based off the window, 32 inches over, and then I need to go up 3 courses of brick. Now I want that box right in the middle. This is a very brittle brick, so I don't want to be drilling any holes, especially large holes around the outside, around the mortar joints. I'll sink my pilot hole here all the way through, and then that will give me my location on the inside. Now additionally, I'm going to use a 3/16 of an inch drill bit, and I've marked 2 other locations. Those are for Tapcon screws that will hold that box on the wall. Now this middle hole, I need to enlarge quite a bit. This is an 1 9/16 hole saw. I'm able to drill it only about halfway through because there is a void in the middle of this brick. So I can just drill the outside to that 1 9/16, and you'll see why I need that coming up. Now, once that's drilled out, I will go back on the inside. Now, unfortunately, you'll see our hole is right on the bottom of that floor joist, not up in the floor joist. So I'm going to drill this now to 1/2 of an inch, and I'll show you what I'll do to protect that Romex. So again, not ideal, but with this brick, I just really have to stay to the middle or it causes a lot of issues. Now what I did to mitigate this is there's a small notch in floor joist. Now you shouldn't get into practice of just notching a bunch of floor joists, but then I have a nailer plate. So I'm able to bring the Romex protected by the nailer plate from the bottom. Again, we don't want to be running Romex on the bottom of floor joists. That's a pinch point. So if anything goes and hits the Romex, it's going to press against the floor joist, and then that's going to increase the likelihood for damage. So I'm protected here. I'll be dropping down, feeding out that 1/2 inch hole, and then going out to the much larger 1 9/16 hole on the outside. Why I need that is because I'm going to be putting a clamp on the back of my box. So I need a lot more clearance there to allow me to secure that clamp down and really hold the Romex in the box like we'd like to. Now let's just talk in general about using Romex here going through masonry. I did ask the audience, almost 2,000 people already voted. By the time you see this video, probably 3,000, 4,000, or 5,000 people already voted, and about 70 to 72% say you should protect Romex with conduit going through brick. But I did reach out to my buddy Joel Walsman from Jefferson Electric out of Indianapolis, Indiana, and Joel also has an awesome YouTube channel called Electric Pro Academy, and I just bounced the same question off him. Now, as always, Joel was a wealth of knowledge, but he pointed me to code 334.10, specifically A2. Now, that's going to give you some direction in terms of NM cable, which is the proper name for non-metallic cabling such as this. Just often I call it Romex, which is more of a brand name that a lot of people have defaulted to opposed to NM cable. Now in that section, it does say that Romex can be placed through voids in masonry block walls. So it does allow from that. Now there's a few other sections there, but in general, from NEC at the highest level, non-metallic or Romex can go through masonry. Does that mean your local inspector is going to allow it? Does that mean it's allowed up in Canada? Not necessarily. So probably not a bad idea to call your local inspector, bounce the question off them, and see what feedback they give you. Remember, our polling results, so over 70% said conduit, even though the NEC code from the highest level doesn't necessarily support that. So Joel didn't necessarily approve my nailer plate here, but let me know down in the comments, when you guys are met with something like this, you want to keep the hole specifically in the center of the brick, but that does not come out ideally in terms of your floor joist. What would you do? What would you do differently than what I did here to protect the non-metallic cable? Now from the outside, I went so large with that hole, 1 inch and 9/16 is the diameter, to fit this cable clamp in. Once I tighten this down, the screws need some clearance, so I'm able to then place the box flush against the brick and then tighten it down with 2 Tapcon screws. Don't forget to put the plugs in here so we make sure we don't get any water in this box once it's fully mounted. And then I do hand tighten the Tapcons just to make sure that I don't strip those out while we're securing it to the brick. So now our box is securely mounted. We have those 2 Tapcon screws in there. We have our white neutral, our black 6 inches past the cutoff sheathing in here, a minimum of 3 inches past the surface here of the end of the box. And then I do have a pre-made pigtail for my ground coming out to a 3-pin Wago 221 lever nut. Now, if you guys need a reference for Wago lever nuts, for the actual box and cover I'm using, or any of the other tools that you'll see me using, you can just look at a link below this video in the description. That'll jump you over to our Amazon store, and specifically here in the electrical section, you'll see all those different tools and the Wago lever nuts with some kits that will give you 2-wire, 3-wire, 5-wire, and the inline splices that will pretty much cover 95% of the different projects you'll be doing around the house. And now with our GFCI outlet, the wiring is very easy. There's a line side and a load side. We'll just be bringing power into the line side here and not have to worry about pulling that off the load side, protecting a standard outlet downstream, which is what the load side's used for. Connecting up the grounds, I'll go ahead and bring my neutral in on the silver screw terminal and my hot black wire into the gold terminal here. Tighten those down, and then we'll set that in place. The manufacturer for this outlet wants you to install it ground facing up, and you can just tell that by the way that the text reads on the outlet correctly when ground is facing up. You can go ground up or ground down, that is your decision. So I'll go finish up the wiring on the inside, and then we'll test this out before putting the cover on. But I just want to point out, if you do not have brick, you don't need to protrude electrical box away from your wall surface. You could use something like an old work box where you're able to put that box on your vinyl siding or whatever type of siding you have. You would outline that here, and then you use like an oscillating tool to cut that out, where then you could inset the box inside your wall cavity, and then you just have a waterproof, I like the in-use covers on the outside, opposed to having your box and the cover on your outside like you do with masonry work like this. But let's jump on the inside and power this guy up so we can test it out. So now with the GFCI installed, you know exactly how much Romex you need. So right here, I'm able to pull the Romex tight. I started to put staples in to control the routing. I installed a 4x4 box, and I actually spliced together the Romex there. Why did I do that? Well, I'm adding another exterior outlet pulling from this same circuit. That is a 15 amp outlet on the outside, the GFCI, running to a 20 amp breaker. So you can run 15 amp outlets on a 20 amp breaker, but you need multiple outlets. So I will be running another one all the way across the other side of the home, also for just convenience to have a few different outlets on different sides of the home. And then from that 4x4, I ran the Romex all the way down to our service panel and then tied into the breaker, obviously hitting my main disconnect, turning the power off to the panel, and then connecting up my neutral, ground, and hot going to that 20 amp breaker. Now, if you need a little more help with that, I will point you in the right direction down in the description of the video. I'll add a few other videos that we've done in the past that will help you with some more detailed explanation of adding an additional breaker, and I'll dive much, much deeper if you need a refresher or just a little bit more information. So I have the breaker on. Let's jump outside and see if that GFCI holds a reset, and then we'll also just test it out with a simple outlet tester. And then I'll show you this crazy thing, which I just got in and I want to test out, which I needed that exterior outlet to plug into. So let's jump outside and see if we're holding that reset. All right, so we definitely have power at this outlet because we're seeing the LEDs light up. I want to press and hold that reset. Everything's looking good with the green LED, but we will test out with this outlet tester, which we'd want to see those 2 amber lights, which you can see are lit up here if I shade those. So we now have power at this GFCI and have confirmed that it works. So last thing I'll do is we'll go ahead and install this cover. What I like about this one, it is all metal, so I think it'll hold up for a very long time and provide you a nice seal even when you're using this outlet. All right, hopefully you're up and running. Let me know if you're having any issues down in the comment section. I do recommend you use some 100% silicone and seal at least the top and the sides to make sure no moisture gets behind the electrical box, between the brick and the electrical box. Now I'm gonna start testing out this thing. This is a micro inverter, and it's supposed to be designed where I can plug 4 solar panels and plug it right into my outlet, generating power for my own home and helping me offset my power bill. I know that sounds crazy. It sounds completely against code, but I'm gonna at least test it out, and I do not have very high expectations for this, but I wanna give it a go. You can check out this video right here, and that is on our other channel called Everyday Solar, where I'll be putting this to the test and sharing the results with you guys. So thanks for joining me on this video, and we'll catch you on that next one. Take care.